Hello and welcome back. I'm Stickmasterluke. We're going to be continuing from where our last tutorial left off in the server script. Let's get started in here now. So you're going to want the event. So first let's define tool. Just as a shortcut. So every time we want to get the script's parent, we can just type in tool instead. Local event equals tool wait for child remote event. What else might we need? Maybe we'll want the handle, so let's just put that in here too. And we might need debris service later, so let's get that one as well. Okay, so get service debris. Get service is a property is a function from game. So we're getting the debris service. So that's debris equals the debris service. Debris. Okay. So let's connect this to this event. Event dot on server event, because it's a server. If you go to view and then you go to object browser, these are all the things that exist inside of Roblox, all the different types of objects. And if you click on one, so we're going to go to remote event. If you click on one of these, you get to see all of the functions and properties and events that this object has. So on a remote event, we have a fire client, fire server, and then we have events that get fired that are on client event and on server event. So for the sword, what we did is we fired the client event, and for this net gun, we're going to be sending stuff to the server, so we're going to be firing the server event. So the server event, let's go to our script, on server event, connect. And we're going to create a function. Alright, we create a function using this event that we found in object browser. It gives us two things. It gives us the player of the client that's sending this information, and then it gives us the tuple arguments. So we get the player, then we get the tuple arguments, which is, if you remember from the sword, we use ellipses to catch all the information that's going to be sent. I'm going to say local tuple equals, and then you put curly bracket, you put the ellipsis in there, the dot 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 in there. So all the extra information that gets handed gets put into a table called tuple. Okay, so if player, just making sure that the player exists. I don't know why I wouldn't. It really should. Yeah. So if the player exists, you know what? Maybe we don't even need to check that. So let's just do if tuple 1. So if the first piece of data that it sends us is fire, then we're going to continue just to make sure that we're getting the right data, because maybe we want to send other stuff through here. So if we go look in our local script, if you remember, we'd say that, oh, we're firing it, and then we're going to be sending the end position, and then we're going to be sending the hit. Okay, so local end pose equals tuple 2. Local hit equals tuple 3. And these are in hard brackets, square brackets. When you're accessing something inside of a list or inside of a table, use the square brackets. Okay, so we're just setting those so that we can access them easily and read our code easily. So what we're going to want to do is, first we're going to want to draw this line that this net gun casts. So when it shoots a ray, we want to visualize this ray. We want to see, and we want everyone to know that they actually shot this gun, shot the ray. So function, we're going to create a new function right here called draw beam. And it's going to have a beam start, beam end, color, fade, delay. Cool. This function might get complicated. We'll see. Okay, so let's start by getting the distance between the beam start and the beam end, the start and the end. So local dist equals beam start minus beam end dot magnitude. So dot magnitude is like distance checking when you subtract. So pretty much when you subtract these, it gets a difference between these two positions, and then you check, and then you convert that to a single number by using dot magnitude, and that single number is actually the distance between these 2 points. Okay, so now distance is that. Now let's create a part. This part is going to be the physical representation in game of showing players that this person had shot. So we're just going to call this beam. Actually, we're going to call it laser. And this laser is going to be a part. So instance.new part, create a new part. Laser.name equals effect. We're going to be calling it effect because if you remember in our local script, in our netgun local script, we ignore things that are called effect right here. So let's close object browser. So we're going to call this effect. So when we're casting a ray with code to see what this ray hits, it's going to go through things called effect. So we're going to call this effect because it is an effect, and we don't want a ray to hit this thing that shouldn't be collidable. Laser dot anchored equals true. So we don't want this thing, we want this thing floating, so we don't want falling, so it's going to be anchored. Want can collide equal to false, so that players can walk through it. What else do we want? Shape. Oops. Laser.shape is equal to block, has a string value. Laser.form factor set to custom. So we're just defining all the properties that we're going to want for this laser. Laser dot laser dot size. We're gonna want this thing to be as small as possible, just because it's only supposed to be a visual effect. So we're gonna put 0.2 by 0.2 by 0.2. Laser dot transparency. You can see through it a little bit. Laser dot, oops, 2 L's. Okay, got rid of that. We're going to want to set the material. To plastic. Might as well lock it. Lock determines whether tools can select it or not. We don't expect it to ever be in the situation where it can be selected, but it shouldn't be selected, so we're going to set locked to true. I'm going to set the top surface. So when you create a new part, like instance.newPart, by default the top surface is set to studs. So we're going to set that to smooth. And same with the bottom surface. Okay, laser dot brick color now. So we're setting the brick color to a new brick color. Actually, we're going to set it to color. So you can see I'm just typing in color here because that's one of the properties that we're going to be sending the draw beam. So if you want this thing to shoot, if you want our tool to shoot like maybe different projectiles while still being in the same tool, you could color the beams differently. So you'd be doing that, but we're not gonna. But we're just gonna leave this in here in case you want to do that. Okay, so here comes the math. It's gonna hit you hard. Okay, so laser.cframe. C-frame of a part is the position along with its direction. It's both its position and its direction in its orientation, not just its direction, but its orientation in the world. So that's what a C-frame is. Position and orientation together. So we're gonna give it. There are many ways to define a new C-frame. You can put it in like a vector 3 or 3 values for just a position. But if you give it two vector 3 values when you're creating a new C-frame, the first one's a position, and the second one is a position from the first position that it should look at. And so we're going to do that. So we're going to do beam end, beam start. And then we're going to multiply this C-frame by a new C-frame. And this new C-frame is going to be half of the distance. So if you can imagine, we're shooting from one point to another. We're drawing a ray from one point to another, say from here to here. Actually, two distinctive things. We're shooting it from the window to this box. This is the start position, this is the end position. So we're creating the C-frame at this position looking that way. So we're going to want to backtrack half of the distance. And this is where we're going to want to create the part. And then from here, we're going to resize it so that it resizes all the way across. So basically what we're doing is getting the center point. We got to get the center point between these two. And by doing that, we're just going to subtract half the distance. So minus dist, which we had defined up here, distance between these 2 points, divided by 2. So now our part is centered and it's looking the right direction. Actually, it's not fully looking the right direction. We're going to be using a head mesh to make it feel, instead of a block, we're going to be using a head mesh. So we're going to, the top of the head mesh it's cylindrical vertically, so we're going to have to rotate this part so it's on its side. So the top is from one point and the bottom is the other point. So we're just going to rotate it by 90 degrees. And to do that, you do C-frame, multiply it by C-frame.angles. And the first value, which is the x in angles, we're going to do math.pi divided by 2. So Euler angles, Euler angles, half of pi is 90 degrees. So we're rotating it by 90 degrees. So we're just kind of turning the part on its side so that the top is facing forward and the bottom is facing backwards. Because we're going to make a head mesh. So local mesh equals instance dot new special mesh. That's the name of the object. It's a special mesh. So we're creating a new special mesh, and we're going to, by default, the special mesh's type is set to head. So that's nice. So we don't need to set that property. But we are going to want to change the scale of the mesh. So mesh scale equals vector 3 dot new. Okay, so want that to be 1, want that to be 1, and its distance is going to be, okay, so if you notice, we made the size of the part 0.2 by 0.2. If you multiply 0.2 by 5, 0.2 is 1/5. If you multiply it by 5, it equals 1. So we want to go the whole distance. We're going to want to do the distance, dist, times 5. So what we're doing is we're rescaling the mesh. The mesh gets multiplied over the part's size. So that's why we have to multiply by 5. We want it to be the distance between the 2 points. So you multiply by 5 to counteract the 0.2 because we want to make it small. So that's that. And then we want to set the parent of the mesh. So mesh dot parent equals laser. Okay, so now it's gonna hopefully look more like a laser because we're using a head mesh. It's gonna look cylindrical. I think we're almost done. We want to put this item into the debris service. So we're going to want to put the laser in a workspace. So laser.parent equals game.workspace. But like I said before in the other video, you don't ever want to put something in a workspace without a surefire way that you know it's going to get eventually cleaned up. So we're going to use the debris service. Add item is a function of the debris service. And the first thing you give is how long you want it to last for. So we're just going to do, oh no, the first item is, hold on, actually, I gotta check real quick. So I'm going to the object browser, going to debris, add item. Oh, so the first value is your item, the second value is how long it lives for. So if you maybe remember in the last tutorial, I think I put it the other way. Let's go back to the, which script was it? Right here. You actually want to change, you want tag to be first, and then you want it to last for 3 seconds. Alright. So that's just fixing up the sword script, and then now here, we want it, what we're gonna want to be cleaned up is the laser, and it's gonna be after the fade delay. So the laser is gonna shoot, or the beam is gonna shoot. It's gonna exist for this long, but this is just the backup safety net. Safety net. But this is a safety. So we're gonna have some effect, some nice effect going on, and so we're gonna remove it ourselves. But in case the script stops running, the debris service will clean it up. Hopefully a second after we're already done with it. So now we do the stuff that makes it, yeah, so now we're going to do the stuff that makes it fade away. So to do this, we're going to define, this is like an animation, so you got to think of it in frames. So local frames equals math.floor fade delay divided by the rate. So we're figuring out how many frames we want in this animation. If you think about a movie is really just a series of frames, a series of pictures. And that's the same thing of what we're doing right now, is we're going to figure out how many pictures we're going to have, how many frames we're going to have. So we're taking how long we want it to fade away, and we're going to divide it by the rate. Let's go define rate right now. Local rate equals 1 divided by 30. This means that 1/30th of a second, that means it will be 30 frames in 1 second. So we're dividing it by the frame rate, and then we're going to math.floor it so that it doesn't have any decimals in the number. Math.floor is like rounding to lowest, rounding lower. So if it's 1.1 gets rounded to 1, 1.9 gets rounded to 1, but 2 gets rounded to 2. 2.1 rounded to 2, 2.9 rounded to 2. So that's math.floor. So we're just rounding it to the lowest whole number, and we're going to run through all these frames. So for frame is equal to 1 comma frames do. So this is a for loop. You give it a starting number and a value that gets changed depending on the starting number, and you give it an ending number. So it runs this code as many times from the starting number to the end number. Okay, so we're going to want it to first wait the rate. So we're going to be waiting and then playing a frame, and then waiting and then playing a frame, or updating it. Alright, so first we want to do, because we're waiting, maybe the laser got cleaned up by something else in the game. Maybe the round ended and the game cleans up all the effects in the game. So we're going to want to make sure that the laser still exists. So if laser, then okay, some more math now. Local percent equals frame divided by frames. So this is how far in the animation we are. So if we're on frame 1 of 10, that means we're right at the beginning. We're 10% of the way through. So So if you're on frame 9, you're 90% of the way through this animation. So now we know the percent at which we are through this animation, and depending on that, we're going to do laser dot cframe, just throwing in some fun, nice looking stuff. Cframe equals laser dot cframe plus wind vec times rate. So what we're doing right here is defining a wind vector. I'm gonna be adding a little bit of beautiful code here. So a wind vector. We're gonna imagine that our game has wind in it, and that when you fire, this little trail that gets drawn, it's gonna blow in the wind, just to make it feel like it's right. So we're gonna define that up here, local wind vec. So this is the direction in which the wind in your game is blowing. You're just gonna imagine that there's wind, and we're gonna make it. It's gonna be a vector 3 because it's the direction. And you can really define it as anything. I've messed around with it a little bit before, and something that seems nice and subtle. Something like this. 2x, negative 1y, and 1z. Okay, so yeah, you're moving it by 1 frame's amount of the wind vector, just so it kind of like fades and blows in the wind. You'll see what it looks like. But the main thing that we made this function for is that this laser can disappear. So when you first shoot it, it shows a trail, and then the trail fades away. So we want this trail to fade away. So we're going to be changing the transparency of the laser. So laser dot transparency equals 0.5 plus % times 0.5. Okay. So when we create it, it's going to start out with, it's going to be half transparent. It's not a solid object. You can kind of see through it. And then in the beginning, it's still going to have like 0.5 plus 0 times 0.5. But then as the animation continues, as you run this through from the beginning to the end of the animation, the percent is going to go from 0 to 1. And so the closer it gets to 1, the more transparent it's going to get, the more closer that transparency is going to be from 0.5 to a full 1 and non-visible, not seeable. So that's what that's for. Okay, so I think we just made our beautiful draw beam function. Oh, one little thing we need to put at the end is to remove it after the animation's done. So it cleans itself up right after the animation finishes. So right when it becomes invisible, it's going to remove itself if it exists. Again, we have to check just in case something else in the game has removed it and it doesn't exist anymore. Okay, and then just in case if our script stops running somewhere in here, because like maybe the tool gets removed, if it gets stopped right here, we put it into the debris service, so that the debris service will clean it up anyways. That's about it for now. Be sure to check in for the next video. Until then, remember, you make the game.